In this question, we are asked to find the solubility of magnesium carbonate in water, and we're only given the Ksp of that compound, 3.5 times 10 to the minus 8. So what we have to think about, we got to start off thinking about the reaction that's occurring. So magnesium carbonate is a solid, and we would label it as insoluble. And so when we put it in water, it will reach saturation fairly quickly, and when it does, we are at a point of equilibrium where the solid magnesium carbonate is in equilibrium with the component ions. So magnesium ions in solution plus carbonate ions in solution. Okay? So because this is a reversible reaction, we are at a state of equilibrium, right? We're at saturation. Okay? Then I can do a rice table to figure out what the solubility is. So I'm just going to set up my table, get my rows, get my columns. Okay, now remember, because this is a solid, we just leave it out of the calculation part. And initially we're going to say that we have none of these ions present, but because this is a reversible reaction and we're at equilibrium, we know that there is going to be a shift to the right to produce some of these ions, and so these zeros are going to change. Okay, well we're going to lose X amount of this magnesium carbonate, and then that means we're going to produce X amount of the magnesium ions and also X amount of the carbonate ions, because if one of these dissolves, then I produce one of these and one of these. So minus X, and plus X. So then, just like every other rice table problem, you bring the columns down, right? And now we just also need our expression for the Ksp. Okay, this is an equilibrium constant, so remember how we write an expression for the equilibrium constant based on the reaction. You've got the products, the concentration of each product multiplied together, raised to the power of their coefficients. In this case, they're both 1. But then we also divide that by the concentration of the reactants, but you leave out solids and pure liquids. So this is the expression for the Ksp, for the equilibrium constant. Well, so now what I can do is I can just do a substitution. These are the equilibrium concentrations of these two ions, so I can just substitute in those terms. And I also know the value of this equilibrium constant. It's given to me, 3.5 times 10 to the minus 8. Right? So now what we want to do is we just want to solve for X. Solve for X. And the reason why is because X answers the question. X is how much of the magnesium carbonate dissolves. It is the solubility of magnesium carbonate. And so since this is basically just X squared equals 3.5 times 10 to the minus 8, all you need to do is just take the square root of that number, and so X is going to be equal to 1.9 times 10 to the minus 4. Okay, and remember, this is a molarity value, and so that is the solubility of MgCO3. Okay, that answers your question.